So here we have a vector question. We're given a vector OA and a vector OB. Now, sometimes we call a vector OA, sometimes we like to call this A because it's the position vector of A. So OA, we can refer to this as A, or A with a little arrow. And OB, we can refer to this as B. So this first part asks for 3A minus 2B. So 3A is just 3 multiplied by that. So that's 12I plus 15J. And 2B is minus 12I plus 2J. So it's just 2 times that. Now they want 3A minus 2B, so we just subtract. 3A minus 2B equals 12. So when you add or subtract vectors, you only add the i's with the i's and the j's with the j's. So 12 minus 12 is 24. And 15 minus 2, because there's a minus sign, is 13. So that's the answer for part A. Then it says find the magnitude of the vector AB in exact form. So first of all, let's find the vector AB before finding the magnitude. So the vector AB is actually the vector OB minus OA. Or some people would write it B minus A. So OB is this and OA is that. So it's the I component minus, because of the minus sign, so it's minus 6i minus 4 is minus 10i. And then that's I, or 1j minus 5j is 4j. So that's your vector AB. But what they're asking for is the magnitude of the vector AB. So the magnitude of a vector is think of it as the length of the vector. So it's the square root of the sum of the square of the components. So minus 10 squared plus 4 squared. So that's square root of 116. You can simplify that using your calculator as 2 square root of 29. So that's your magnitude of AB, and they want it in exact form. So exact form means you shouldn't write it as a decimal. You leave the surd as a surd. Now the next question is talking about the midpoint of AB. So how do you find the midpoint of AB? So if you think of the 2 points A and B like that, and that's the vector AB, it's the vector from A to B, the midpoint of AB, they're calling M. You can find that by adding the I components of A and B and the J components of A and B. And they're asking for the position vector. So that if you think of the coordinates of A as being 4 and 5, and the coordinates of B as being -6 and 1, so we can do it with coordinates rather than vectors. So we can find the coordinates of M like this. M is 4 plus -6 over 2, 5 plus 1 over 2. So if you notice, we add the x components and we divide by 2, and then we add the y components and we divide by 2. So you can think of the formula for this as being x1 plus x2 over 2, y1 plus y2 over 2. So the coordinates of M will be 4 minus 6 is -2 over 2 is -1. 5 plus 1 is 6 over 2 is 3. So you can write the position vector OM as -I plus 3j. So these are the coordinates. This is the position vector. And we can find one from the other. So let me just write that out. These are the coordinates. And this is the position vector. So the coordinates are just written x, y, and the position vector is written I, j, and the question is asking for the position vector. So that's the answer. Another way of finding this is simply adding OA plus OB over 2. We can do it that way as well, if you like. We can say, or OM equals OA plus OB over 2. So that would be -I, no, actually. Yeah, so you add OA and OB, and the answer will be -2I plus 6j over 2, and that will give you -I plus 3j, because you can divide that and you can divide that. So you get the same answer whether you use coordinates or whether you use vectors. It's probably slightly easier to do it this way. Okay. It then says find the position vector of the point C such that OABC is a parallelogram. A parallelogram is a quadrilateral, that's a four-sided shape, where the opposite sides are both parallel and equal in length. So OABC. So let's try to draw that. So you've got the coordinate axes, and you've got O, you've got A. It doesn't matter where A, B, C are drawn. Let's just establish that we have OAB, and the final point is C. So OAB, and then we need a fourth point, C. So if we just move this like that, we now have a shape. One side, two sides. Now where's C going to be? Can we put C here? Or C here? Or C here? Well, it needs to be a four-sided shape, and the sides need to be parallel. So we know that C is somewhere along this line here, because this has to be parallel to this. But this length has to be the same as this length, so that this will also be parallel to this. So we can imagine that C is going to be somewhere here. Okay, so I haven't found C, I just have illustrated where I think C should be. Now, we know this vector, OA, that's just what we called A. We know this vector, AB, we found it. Now we want to find OC. That's what the question says. Find the position vector of C. That's just another way of saying OC. So how am I going to find OC? Let me highlight that. That's what the question is asking for. OC. So one way of getting from O to C is going from O to A, and then A to B, and then B to C. But do we know BC? Well, we know that BC is parallel to OA, so if this is A, then this must be minus A, because it's the same direction, it's the same length, so it's just minus A. And this, I think it was AB, that's just B minus A. B minus A. So we've got A plus B minus A plus minus A. So we can write the answer like this. OC equals A, that's that, plus B minus A, that's that, minus A, that's that. So we go 1, 2, 3, and that's the equivalent of OC. So if you simplify that, you'll get that cancelling with that, and you'll end up with B minus A. And actually, we could have said that from the beginning. This is equal to this because they're parallel and equal. So that was a bit of a wasted time. We could have just said OC is equal to AB, which is B minus A. So a smarter way would have been to say OC equals BA, and we've already found BA. Is it BA? Sorry, AB. I think we already found AB up there somewhere. Yeah, so AB is just that. So that's the answer to part D. This is the position vector of OC.